this is page 625. Again, we read the question carefully, and we notice it says solve and not prove. So we're allowed to work on both sides. I'm going to rewrite the question here. Again, we run into an initial problem that this question has two trig functions. It has sine x and it has cos x. So then we have to think, is there a way with our identities that we could get everything with cos? Yes. We've done this before. This was a question we did in chapter 6 as well. I can take, because I have the big idea that sine squared x plus cos squared x equals 1, you're going to get really good at going, oh, so that means sine squared x is equal to 1 minus cos squared x. Important to note, that is only true if they're squared. At no time can you say that sine x is equal to 1 minus cos x. That's not true. The only thing you can do is if they are squared. But since they're squared, I can take the sine squared x and I can replace it with 1 minus cos squared x. I have brackets here. I could distribute this negative 2 and see what I have. And once I have that, I still have some like terms. I notice that I have a quadratic equation. So that means I'm either going to have to factor or use my quadratic formula. If you have a quadratic equations, we normally write it with the squared item first, followed by just the negative 3 cos x. And 3 minus 2 are like terms that'll leave me with plus 1. And again, we're going to try factoring this first. We might have to use a quadratic formula. If we could factor it, the only way to get 2 cos squared would be 2 cos x and cos x. So sometimes these ones that are factoring are really quite easy because there's basically only one option that you have. Same thing, the last number. The last number is a 1. The only whole numbers that multiply to give you 1 are 1 and 1. For factoring, we never worry about going into fractions or decimals or anything like that. If it had to go to fractions or decimals, then you'll use your quadratic formula. And now we have to check, is it possible to use the outside and the inside? 2 cos x and 1 cos x ever to get a minus 3? Yes. It would be possible if the outside was negative 2 and the inside was negative 1. And then once you've got your signs in there, do the check. Do my first terms give me 2 cos squared x? Yes. With the negatives, do I get a plus 1 still at the end? Yes. Because negative 1 times negative 1 is plus 1. And we did check the outside and the inside already, and it worked. So it does factor nicely. We can split it right here. And this tells us that cos x can equal 1/2, or cos x can equal 1. 1/2 on your pie plate? Yes. What family for cos has 1/2? That's your pi over 3 family. You would look in quadrant 1 and quadrant 4. For cos x equals 1. That ever on our pie plate? Yes, it happens right here. It happens at 0 and at 2 pi. So when we're solving, we're going to naturally solve once around the whole circle. When we're done, we should always go back to the original question and read the domain. I didn't do that in the last question, but I remembered it was 0 to 2 pi. The last one didn't matter. But this one, when I go back up, or struggle to go back up, and look, the domain is just 0 to 3 pi over 2. Can you see that that cuts out quadrant 4? So we're going to go back to our answers. 2 pi is not included, because we're only going up to 3 pi over 2. Also, 5 pi over 3 is in quadrant 4. We would have to take that answer out as well. So our only answers are 0 and pi over 3. But I would like you to still, like if they asked for the general solution next, you would have to use all your answers from 0 to 2 pi. So it's a good strategy to always solve once around but then check your domain at the end. What were the questions that they were looking for? And just like the last one from number 4, circle question 10 as well.